Welcome dear students to lecture number 2 of the chapter Classification of Elements and Periodicity in Properties. Let me remind you that in first lecture we discussed the history of the periodic table starting from the work of Dobriner to the work of the Lothar Meyer. We discussed the law of triads, we discussed the cylindrical table presented by the chancourtois, then we discussed the law of octaves presented by the Newland, and then finally we discussed the Lothar Meyer curve. Now, in this lecture, we will focus on the work of the Russian chemist Dmitri Ivanovich Mendeleev, who is also considered as the major contributor towards the development of the modern periodic table, and that is why he is called as the father of the modern periodic table or founder of the modern periodic table. Dear students, it was 1869 and 63 elements were discovered at that time, and Mendeleev arranged all those 63 elements in form of a table that later on was called as the Mendeleev's periodic table. Now Mendeleev used the concept of the cards. He actually took 63 cards, and on one card he wrote all the physical and chemical properties of one element. So on 63 cards he mentioned physical and chemical properties of all 63 elements, and then he placed those cards on the wall and he observed the elements that have same physical and chemical properties, and the elements having same physical and chemical properties, he placed their cards on the wall in the form of the vertical column, which later on in his periodic table were called as the groups or families. So the elements having same physical and chemical properties on a wall, they were placed one above each other, and that one above each other arrangement was a group which later on was called as the family or group of the Mendeleev periodic table. So he used the concept of the cards to arrange all the 63 elements known at his time. And after arranging those elements on the wall and observing the repetition in their physical and chemical properties, then he presented Mendeleev's periodic law, which states that the physical and chemical properties of elements and their compounds are the periodic function of their atomic mass. Now, simply we can say that this law states that the physical and chemical properties of the elements and their compounds that depend upon the atomic mass of that element. You can say that atomic mass is basically the fundamental property which decides the physical and chemical properties of an element, and not only element, also of its compounds. And when you arrange the elements in the ascending order of their atomic masses, then the elements with the similar physical and chemical properties, they repeat themselves after regular intervals. That was the Mendeleev's periodic law. So the gist of the Mendeleev's periodic law is that number one, atomic mass is the fundamental property of an element, and number two, when the elements are arranged in ascending order of their atomic masses, then the elements with the same physical and chemical properties are repeated after the regular intervals. And on the basis of his periodic law, he arranged the elements in a tabular form, which is called as the periodic table. Periodic table is basically the tabular form in which elements are arranged according to their properties. So, depending on the Mendeleev's periodic law, he formulated a table of the elements that was called as the Mendeleev's periodic table, and this one is actually the Mendeleev's periodic table. You can see that there are some vertical columns in Mendeleev's periodic table. They are called as the groups or families, and they are horizontal rows in the Mendeleev's periodic table. These are named as periods nowadays. So that was basically the tabular form which was called as the Mendeleev's periodic table. Now let us discuss some merits and demerits of this periodic table presented by the Dmitri Mendeleev. The first merit was that in 1869, dear students, there was no concept of the subatomic particles. You know, the first subatomic particle that was discovered in almost 1886 or 87. So there was no idea of the internal structure of the atom at the time of the Dmitri Mendeleev, and the instrumentation was not that much developed as we see nowadays. So instead of lack of facilities, lack of the information of the internal structure of the atom, still arranging the 63 elements in that form, that was a big achievement. So the first merit was the innovation of the periodic table itself. So its innovation to arrange the elements in the form of the periodic table. That was the first success, that was the first merit of his work. Then a very, very important concept. There were some elements that were having wrong atomic masses at the time of Mendeleev. Mendeleev redetermined their atomic masses and then their correct atomic masses was seen. Just like beryllium, his atomic mass was 14 and Mendeleev corrected it to 9 in order to arrange it in his periodic table. So Mendeleev corrected the atomic masses of some elements. Then the main merit of his periodic table was the gaps that he left for the undiscovered elements. There were some elements that were not discovered at the time of Mendeleev, but in his periodic table, he left the gaps or the places that these elements are not yet discovered, but they will be discovered in future. And when they will be discovered in future, they will be having these properties and they will be fitted in these gaps left in the Mendeleev's periodic table. He left a gap just below aluminium here, and he named that undiscovered element as EKA aluminium. My dear students, EKA is a Greek word which means like. So EKA aluminium means aluminium like. He left a place of undiscovered element below aluminium and he named this undiscovered element as the EKA aluminium. And similarly, he left an empty space here just below silicon and titanium and he named it EKA silicon, means silicon like. And similarly, these are some gaps that he left. So these were the gaps left for the undiscovered elements. And he not only left the gaps, but he also mentioned the properties of the aluminium, EK aluminium and EK silicon, that these elements will be discovered in future and they will be having this melting point, boiling point, and they will be having properties like aluminium and silicon because they will be members of the aluminium and silicon family. And dear students, surprisingly, in the lifetime of the Mendeleev, these two elements were discovered. The element named EK aluminium by Mendeleev was discovered in 1875, which nowadays is called as gallium. And gallium has same properties. His actual properties are same as mentioned by the Dmitri Mendeleev. Similarly, in 1886, the element called EK silicon by the Mendeleev was discovered and it was named as germanium, and the properties of the germanium which were determined experimentally were just like the properties mentioned by the Mendeleev. That was a big achievement, that not only he arranged all elements of his time, but he also left gaps for the undiscovered elements. And leaving gaps is something else, but mentioning their properties and then those properties were experimentally verified later on, that was again a big achievement of the Mendeleev. And Mendeleev in his lifetime gained huge fame and he was awarded by different medals, different prizes by the different countries of the world because of his contribution to this development of the periodic table. Now, there were some demerits in the Mendeleev's periodic table, and according to my opinion, these demerits were just because of the lack of the information at that time, lack of the development of the instrumentation at that time. The first demerit was that he left no place for hydrogen. Dear students, hydrogen is one of the very unique elements of the periodic table. In Mendeleev's periodic table, he placed hydrogen in group 1 and he placed hydrogen with alkali metals lithium, sodium, potassium. Dear students, you know hydrogen is a non-metal and alkali metals are pure metals, so they do not have same properties, so they should not be placed in the same group. But this was the wrong placement of the hydrogen in the Mendeleev's periodic table. Just like he left some empty spaces for undiscovered elements, he should have also left some empty space for hydrogen or some other slot for hydrogen instead of mixing hydrogen with the alkali metals. So that was the first mistake, that was the first demerit, that hydrogen should be placed separately, it should not be mixed with the alkali metals because it is not a member of the alkali metal family. The second was no place for noble gases. You can see that in entire periodic table of the Mendeleev, there is no place of noble gases. In fact, Mendeleev always denied the existence of the noble gases, and then interestingly, when Mendeleev was spending the last year of his life, noble gases were discovered nearly in 1907. But where to place the noble gases? Mendeleev left no place for the noble gases. That was the second drawback, that he left no places for the noble gases, and leaving the place for the noble gases is another thing, but he always denied the existence of the noble gases. He never believed that in future the noble gases will be discovered. The third, that was wrong grouping. Dear students, you can see the group 1, lithium, sodium, potassium, they are three alkali metals, and now they are placed with copper, silver, gold. These are three coinage metals which are used to make coins. Now, dear students, alkali metals are very soft and very reactive metals, and the coinage metals, silver, gold, and copper, they are very inert metals and they are very hard metals. The properties of alkali metals and coinage metals, they are not like each other. So that was the wrong grouping. There must be two different groups for these, one for alkali metals and other for the coinage metals. Placing them in the same family, that was a mistake by the Mendeleev, and it became a demerit of the Mendeleev's periodic table. Next was wrong placements. Now just look at this, iodine and tellurium. This one is tellurium and this one is iodine. The atomic mass of tellurium is 128, that of iodine is 127. According to ascending order, the iodine must be placed first because of its smaller mass, and then tellurium should be placed next because of its greater mass. Then the ascending order will be fulfilled. But he placed tellurium first, even though it has greater mass, and iodine after that, even though it has smaller mass, just to maintain the consistency of the groups in his periodic table. Because iodine was having similar properties to other halogens, if he will place iodine on the place of the tellurium, then the properties of the iodine, they do not match with the oxygen, sulfur, and other members of this group. So it was basically his mistake that he placed iodine next to the tellurium, although the iodine was having smaller mass, and this is not according to the ascending order of the atomic masses. But Mendeleev argued that it is quite possible that the atomic mass of iodine and tellurium are wrongly determined, just like the atomic mass of the beryllium. So he said that in future it is possible that the atomic mass of tellurium and iodine will be redetermined and his placements will be justified. But this never happened, because in the modern periodic table, even they are having the same masses and their placements are different. So that was another mistake, because he disobeyed the ascending order at some places in his periodic table. My dear students, then later on the concept of isotopes were discovered. When you are arranging the elements on the basis of their atomic masses, then isotopes are the atoms of the same element having different masses. You know, nowadays hydrogen has three isotopes: protium, deuterium, tritium, mass number 1, 2, 3. So there must be 3 slots for hydrogen in the periodic table if the periodic table will be made according to the atomic masses. But there was again no place for the isotopes in the periodic table of the Mendeleev. So these were some demerits of the Mendeleev's periodic table, and these demerits will be improved and you will get the modern periodic table. So modern periodic table is not an innovation, it is just an improved form of the Mendeleev's periodic table. And then, my dear students, in 2019, United Nations named this 2019 as the International Year of the Periodic Table, because starting from the 1869 to 2019, that was the 150th anniversary of the periodic table. That's why United Nations named 2019 as the International Year of the Periodic Table. So these were some contribution of the Dmitri Mendeleev arranging the elements in the form of the periodic table. Our next lecture will be about how the improvements in the Mendeleev's periodic table were made and we got the modern periodic table. So next lecture will be about the modern periodic table. I hope so that this lecture will be quite understandable for you people. If you feel any query, any question, you can ask in the comment section. See you in the next lecture. Till then, take care.